Number 12 of May 2021, time zone 2, paper 2. Now we're asked to show that f is an even function, so we can solve this by solving for f of negative x. So arc sine, I'm gonna write arc sine as sine inverse. So sine inverse of negative x squared is simply x squared minus 1, x squared plus 1. So since f of x is equal to f of negative x, the function is even. Okay, part B. By considering limits, show that graph of y equal to f of x has a horizontal asymptote and state its equation. So you can actually graph this because you have GDC and see that it really has a horizontal asymptote. Now we're asked to use limits here, so I'm going to write the limit as x approaches infinity of sine inverse of x squared minus 1. So I'm going to factor out the x squared, similar to what Revision Village did here, right? So x squared 1 minus 1 over x squared, then x squared 1 over x squared times 1 plus 1 over x squared. So x squares cancel out, and so as x approaches infinity, this is going to be 1 over infinity, which is 0, and so the limit as x approaches infinity will become of sine inverse of 1. Now sine inverse of 1 is simply pi over 2, so the answer to this limit is pi over 2. And if you want to state its equation, well, it's y equal to pi over 2. Part C of question number 12. So we're asked to show that f prime of x is equal to 2x. Alright, fine. So I'll write that right here because I need space and I need to look at f of x as well. So f of x is equal to arc sine of x squared minus 1 over x squared plus 1. So from our data booklet, we know that, let me bring the data booklet. Yeah, so we know the derivative of arc sine is 1 over radical 1 minus x squared. So 1 over radical 1 minus x squared minus 1 over x squared plus 1, all of this squared. And of course you have to use the chain rule as well, right? So chain rule, and then you have to use the quotient rule. So x squared minus 1, the derivative of x squared minus 1 is simply 2x. 2x times x squared plus 1. Excuse me. Excuse me, alright. And then minus the derivative of x squared plus 1, which is again 2x times x squared minus 1. All of this over x squared plus 1 squared. Now, before I continue, let me just simplify this. So 2x times x squared is simply 2x cubed plus 2x minus 2x cubed minus plus 2x. So the 2x cubes cancel out and we'll be left with 4x. Alright, so if I just quickly copy and paste this, because it will take a long time for me to write all of it. Okay. So this will be 4x over x squared plus 1 square, so 4x. And then I'll use common denominator here. So this is going to be x squared plus 1 squared minus x squared minus 1 squared over x squared plus 1 squared, right? And so I'm going to shift this x squared plus 1 squared from the denominator of this fraction to the numerator of the main fraction. So I'll get x squared plus 1, right, because it's under radical as well. And then now what? Yeah, so over radical x squared. Perhaps it's better if we expand the terms in our denominator as well. So x squared plus 1 squared is simply x to the power of 4 plus 2x squared plus 1, right? And then minus x to the power of 4 plus 2x squared minus 1. So your 1's cancel out and your x to the power of 4's cancel out. You'll be left with 4x squared in the denominator, and over here you just have your x squared plus 1 squared. So now you can cross multiply and you'll get rid of your x squared plus 1 in the numerator, and you'll only have a 4x in the numerator, and radical 4x squared times x squared plus 1 in the denominator. So you can simplify this. You'll take out the 4 and that will be a 2. 4 divided by 2 is simply 2, so 2x over radical x squared plus 1. This is what we were asked to find as well. Okay, now by using the expression for f prime of x and the result radical x squared equal to absolute value of x, show that, okay, we're asked to show that f is decreasing. So 2x is simply absolute value of x plus 1, right? And show that f is decreasing for x less than 0. X is less than 0, right? But despite x being less than 0, your radical x will be greater than 0, and your radical x plus 1 will also be greater than 0. So based on this, because your numerator is greater than your denominator is greater than your numerator, your f of x will decrease. Alright, part D. Where is it? I think this is the one. No, it's not. Perhaps this is the one. Alright. Part D, we're given a function g defined by g of x equal to arcsine of x squared minus 1 over x squared plus 1. I think it was the same thing. The same thing as f of x. But this time we're asked to find an expression for g inverse of x. So g inverse. Let's see, y squared minus 1, y squared plus 1. Right, so we'll move the sign to the left. We'll have y squared minus 1. Okay, this is easy, I think. Is it? Did I just jinx it? Okay. I'll move this to the left. So sine of x y squared plus sine of x equal to y squared minus 1. And then I'll move the y squared to the left. So that'll be y squared 1 minus sine of x minus 1, right? And here we'll have a if we move this to the right, we'll have negative sine of x minus 1, right? So y squared will be equal to negative sine of x minus 1 over sine of x minus 1. Is that right? And we can then take the radical, right? Let's see. y squared 1 plus sine of x over 1 minus, okay, so I guess I can factor out the negative, so that's going to be 1 plus sine of x, and then here is going to be 1 minus sine of x, right? So the negatives cancel out, so y squared will be 1 plus sine of x over 1 minus sine of x. Alright, so that seems right. Okay. Then you can take the radical as well to finalize your answer. So g inverse of x is radical 1 plus sine of, okay, that wasn't too bad. State the domain of g inverse of x. Its domain. Well, it obviously, so it can either be, yeah, so the denominator cannot be 1, cannot be 0, I'm sorry. So sine of pi over 2 is a no-no, right? But yeah, so negative pi over 2 to, so negative pi over 2 to pi over 2. That makes sense, right? So 1 plus sine of negative pi over 2 is 0, so that is fine, right? But then it can't be pi over 2 because your denominator will be 0 in that case. Alright, last part, sketch the graph of y equal to g inverse of x, clearly indicating any asymptotes with their equations and stating the values of any axis intercepts. Asymptotes. So I guess this is one asymptote, this is another, and from the looks of it, y should be greater than 0, greater than or less than 0, yeah, because we were told in the equation that, look, where is it? We're told somewhere. Where am I saying it's a function? Oh, I'm sorry, here. So x greater than or less than 0. This is greater than or equal to 0. So this is for g of x. Now this will be the range value for g inverse of x. And then you can solve for the y-intercept as well. So g inverse of 0 will be simply 1 plus sine of 0, which is 0, right? So it's going to be 1. So this is your y-intercept. So I guess it looks something like that. Yep. Gotta respect the asymptotes as well. That's a rough graph, a rough sketch, but you get the gist of it.